The warnings were provided well ahead of time, but they were either ignored or downplayed until a lot of the predictions started coming true. Welcome to the Why in History. I am Ajay Kaul, and today we are talking about the biggest threat that mankind is facing with respect to its existence. Today we are talking about climate change, how we got here, and what steps we can take to slow and reverse the trajectory of global warming. We start our discussion around the year 1800, when the world population had just reached 1 billion. And back then, the concept of warming the planet was actually even welcomed, mainly because it was thought that as the atmosphere warmed up, we could hope to enjoy more equable and better climates, especially in the colder regions of the Earth. In 1824, French physicist Joseph Fourier described the Earth's natural greenhouse effect. He wrote that the temperature of Earth can be augmented by the interposition of the atmosphere because heat in the state of light finds less resistance in penetrating the air than in repassing into the air when converted into heat. A greenhouse is a building with glass walls and a glass roof, and greenhouses are used to grow plants such as tomatoes and tropical flowers. A greenhouse stays warm inside, even during winter. How? In the daytime, sunlight shines into the greenhouse and warms the plants and air inside. At nighttime, it's colder outside, but the greenhouse stays pretty warm inside. That's because the glass walls of the greenhouse trap the sun's heat. The greenhouse effect works pretty much the same on Earth as well. Gases in the atmosphere, such as carbon dioxide, trap heat similar to the glass roof of a greenhouse, and these heat-trapping gases are called greenhouse gases. This is exactly what Joseph Fourier was trying to tell us, that during the day, the sun shines through the atmosphere, Earth's surface warms up in the sunlight, and at night, Earth's surface cools, releasing the heat back into the air. But some of the heat is trapped by the greenhouse gases in the atmosphere, and that's what keeps our Earth warm and cozy at 58 degrees Fahrenheit on an average. And in 1861, Irish physicist John Tyndall showed that water vapor and certain other gases create the greenhouse effect. The other gases besides water vapor are carbon dioxide, methane, and nitrous oxide. These are the major ones, and then you have a host of other gases as well. The first warnings about global warming came about in the 1930s. British engineer Guy Stewart Callender noted that the United States and North Atlantic region had warmed significantly on the heels of the Industrial Revolution. Callender's calculations suggested that a doubling of CO2 in Earth's atmosphere could warm the Earth by 2 degrees Celsius or 3.6 degrees Fahrenheit. He continued to argue into the 1960s that a greenhouse effect warming of the planet was already underway. Callender's claims were largely met with skepticism, but he managed to draw attention to the possibility of global warming. And that attention played a part in garnering some of the first governmental funded projects to more closely monitor climate and CO2 levels. The most famous among those research projects was a monitoring station established in 1958 by the Scripps Institute of Oceanography on top of Hawaii's Mauna Loa Observatory. Scripps geochemist Charles Keeling was instrumental in outlining a way to record CO2 levels and in securing funding for the observatory, which was positioned in the center of the Pacific Ocean. Data from the observatory revealed what would become known as the Keeling Curve. This upward sawtooth-shaped curve showed a steady rise in CO2 levels, along with short jagged up and down levels of the gas produced by repeated wintering and greening of the northern hemisphere. The dawn of advanced computing in the 1960s began to predict outcomes of the rise of the CO2 levels made evident by the Keeling Curve, and computer models consistently showed that doubling of CO2 could produce a warming of 2 degrees Celsius or 3.6 degrees Fahrenheit within the next century. And then the 1970s brought about a new scare: global cooling. Yes, people were becoming more concerned about pollutants harming the atmosphere, and some scientists theorized that the pollution could actually block sunlight and cool Earth. And in fact, Earth did cool somewhat between 1940 and 1970 due to a post-war boom in aerosol pollutants, which reflected sunlight away from the planet. The idea that sunlight blocking pollutants could chill Earth caught on in the media, and in 1974 there was a Time magazine cover article titled "Another Ice Age." But the brief cooling period ended and temperatures resumed their upward climb, and warnings by a minority of scientists that Earth was cooling were dropped. And part of the reasoning was that while smog could remain suspended in the air for weeks, CO2 could persist in the atmosphere for centuries. The UN Scientific Conference, also known as the First Earth Summit, was held in Stockholm, Sweden from the 5th to the 16th of June 1972, and it adopted a declaration that set out the principles for the preservation and enhancement of the human environment, and also set an action plan with recommendations for international environmental action. It raised the issue of climate change for the first time, warning governments to be mindful of activities that could lead to climate change and evaluate the likelihood and magnitude of climate effects. The summit also proposed the establishment of stations to monitor long-term trends in the atmospheric constituents and properties which might cause meteorological properties that could lead to climate change. And these programs were to be coordinated by the World Meteorological Organization to help the world community to better understand the atmosphere and the causes of climate change. Around this time, as the United States was reeling under the effects of the oil crisis due to a hard dependency on foreign oil, one individual broke off from the pack and emerged as a big proponent of renewable energy: US President Jimmy Carter. And on June 20, 1979, President Carter unveiled 32 solar panels atop the White House. And in his State of the Union address that year, President Carter presented an ambitious plan to put America on a clean energy path, 20% of energy from renewable sources by the year 2000. Part of his idea was to go far beyond simple hot water solar collectors and direct government research funds towards the development of photovoltaic cells, the kind that could put energy into the grid. Yes, this was in 1979. Wow. Then what happened? Well, what happened was 1980. Ronald Reagan got elected president in the United States, and Margaret Thatcher became the Prime Minister of the United Kingdom. And that started 2 decades of backlash against environmental understandings and activism. And essentially, they were joined by other partners like Canada, Australia, and others in a belief that nature would self-adjust and we had limitless resources. But the early 1980s saw a sharp increase in global temperatures. Many experts point to 1988 as a critical turning point when watershed events placed global warming in the spotlight. The summer of 1988 was the hottest on record, although many since then have been hotter, but 1988 was the hottest on record, and it also saw widespread drought and wildfires within the United States. Scientists sounded the alarm about climate change, and NASA scientist James Hansen delivered testimony and presented models to the Congress in June of 1988, saying he was 99% sure that global warming was upon us. 1 year later, in 1989, the Intergovernmental Panel on Climate Change, IPCC, was established under the United Nations to provide a scientific view of climate change and its political and economic impacts. As global warming gained currency as a real phenomenon, researchers dug into possible ramifications of a warming climate. Among the predictions were warnings of severe heat waves, droughts, and more powerful hurricanes fueled by rising sea surface temperatures. Other studies predicted that as massive glaciers at the poles started melting, sea levels could rise between 11 and 38 inches by the year 2100, enough to swamp many of the cities along the east coast of the United States. By now, the writing was on the wall, and government leaders began discussions to try and stem the outflow of greenhouse gases to prevent the most dire predicted outcomes. So the first global agreement to reduce greenhouse gases was the Kyoto Protocol, which was adopted in the year 1997. From the United States, the protocol was signed by President Bill Clinton, and it called for reducing the emission of 6 greenhouse gases in 41 countries plus the European Union to 5.2% below 1990 levels. And the target period was 2008 to 2012. But in March 2001, President George W. Bush took office and announced that the United States would not implement the Kyoto Protocol, saying that the protocol was fatally flawed and that there were concerns that it would hurt the US economy. By now, the discussion around climate change had become heavily politicized, and in the year 2001, the IPCC issued its third report on climate change, saying that global warming was very likely with highly damaging future impacts. And 5 years later, in 2006, former Vice President Al Gore weighed in on the dangers of global warming with his debut film, An Inconvenient Truth. Al Gore and the IPCC jointly won the 2007 Nobel Peace Prize for their work on behalf of climate change. The skeptics around global warming continue to expand, and among them was the future US President, Donald Trump. On November 6, 2012, Trump tweeted, "The concept of global warming was created by and for the Chinese in order to make the US manufacturing non-competitive." In 2015, with President Barack Obama in power, the United States would sign on to another milestone treaty on climate change, the Paris Climate Agreement. In that agreement, 197 countries pledged to set targets for their own greenhouse gas cuts and to report their progress. The backbone of the Paris Climate Agreement was a declaration to prevent a global temperature rise of 2 degrees Celsius or 3.6 degrees Fahrenheit. Many experts considered 2 degrees Celsius of warming to be the critical limit, which if surpassed will lead to increasing risk of more deadly heat waves, drought, storms, and the rising global sea levels. But in 2016, Donald Trump was elected President of the United States, and he immediately declared that the US would withdraw from the Paris Treaty. Trump cited onerous restrictions imposed by the accord and stated that he could not in good conscience support a deal that punished the United States. Global warming, though, continued, and in October 2018, the IPCC issued a report that concluded that rapid, far-reaching actions were needed to cap global warming at 1.5 degrees Celsius or 2.7 degrees Fahrenheit and avert the most dire, irreversible consequences for the planet. In August 2018, Swedish teenager and climate activist Greta Thunberg began protesting in front of the Swedish parliament with the sign "School Strike for Climate." And her protest received global visibility, and by November 2018, over 17,000 students in 24 countries were participating in climate strikes. Recently, the UN Climate Action Summit reinforced that 1.5 degrees Celsius is the socially, economically, politically, and scientifically safe limit to global warming by the end of the century, and it set a deadline for achieving net zero emissions to the year 2050. So how are humans impacting climate change and the greenhouse effect? Well, the primary reason often is cited as the burning of fossil fuels like coal and oil, which ends up putting more carbon dioxide in our atmosphere, which leads to more heat getting trapped within the earth, and that causes the earth to warm up. And what can reduce the greenhouse effect on earth? Well, for starters, plants. Plants help to balance the greenhouse effect because they, in different forms, from giant trees to tiny phytoplankton in the ocean, take in carbon dioxide and give off oxygen. So the ocean also absorbs a lot of excess carbon dioxide in the air. Unfortunately, the increased carbon dioxide in the ocean changes the water, making it more acidic, and this is called ocean acidification. And more acidic water in the oceans is harmful to creatures like shellfish and coral. But the most important factor in climate change is often mentioned in a very casual way: the human population itself. In 1800, the world population touched 1 billion, and at that time, the atmospheric carbon dioxide was 284 parts per million. In 1940, 140 years later, the world population almost doubled to 2.4 billion, and at that time, the estimated carbon dioxide in the atmosphere was 311 ppm. And within a short span of just 60 years, in the year 2000, the world population tripled to 6.07 billion, and the estimated atmospheric CO2 was 369 ppm. And the world population is expected to grow to at least 9 billion by mid-century. 9 billion. And the UNEP, the United Nations Environmental Program, estimates that it requires 54 acres to sustain an average human being today with respect to food, clothing, and other resources extracted from the planet. Clearly, the population growth is not sustainable. So even though we may change our consumption habits, switch to renewable sources of energy, till we control the population explosion, we will reach a point wherein human beings will not be a sustainable proposition on this planet. And on that note, we conclude this section of today's program. On to the quiz section. Question from the last episode. Why was Robert J. Oppenheimer blacklisted and stripped of his job at the Atomic Energy Commission in 1954? After building the atomic bomb, Robert J. Oppenheimer and his team of physicists realized what a destructive weapon they had created. And subsequently, Oppenheimer spent a lot of energy trying to convince the government and Harry S. Truman about placing international controls on nuclear weapons. And more specifically, he was strongly opposed to the design and manufacture of the deadlier hydrogen bomb. This irked the establishment, and subsequently, Oppenheimer was stripped of his job at the Atomic Energy Commission. So the answer is B, his opposition to the development of the hydrogen bomb. On to the question for this episode. Which three countries, despite being major greenhouse gas emitters, have not yet ratified the Paris Climate Accord? Is it A, Russia, Sudan and Angola, B, Iran, Turkey and Iraq, C, Libya, Iran and Pakistan, or D, Israel, Australia and Iceland? Once again, which three countries, despite being major greenhouse gas emitters, have not yet ratified the Paris Climate Accord? A, Russia, Sudan and Angola, B, Iran, Turkey and Iraq, C, Libya, Iran and Pakistan, or D, Israel, Australia and Iceland? The answer will be provided in the next episode. That's all we have in this episode. In the next episode, we dive into the refugee crisis across the globe and look for the reasons behind the crisis, the source of the unrest, and if there are any solutions that could prevent such crises from happening in the future. Till then, stay safe and keep looking for the why in history.